Hello everybody, today we'll be solving a related rates problem. And the problem is asking us to find the distance s as respect to time. So what that means is as the planes are flying toward each other, this distance s will get smaller and smaller. So that is essentially what we want to find. The given variables that we are provided with is the plane that is flying toward west. Its initial position is 225 miles. And the plane that is flying toward south, its initial position is 300 miles. We are also given the speed of each plane. For the plane that is flying the west direction, it is flying at 450 miles per hour. And for the plane that is flying in the y direction, flying towards south, its speed is 600 mile per hour. So in calculus term, this is dy over dt. This is dx over dt. This is the x initial position. This is the y initial position. And what we want to find is ds over dt. Now that we have all of the values, we can start writing our equation and solve for the problem. We know that from the right triangle rule, this is 300, 225 miles, and we want to find the initial position of the two planes being apart, which is s, initial. And for the Pythagorean theorem, we can write it as s initial square is equal to x initial square plus y initial square. To solve for s initial, we just take the square root of x initial square plus y initial square. And if we plug in the value, we would have 225 square plus 300 square, which would give us 375 miles for s initial. I'll get rid of this to make some space. Let's label this 375 miles. With that solved, we can now find the rate in which s is changing. And the way that we would do that is we would take the derivative of the Pythagorean theorem formula. So s squared is equal to x squared plus y squared. To take the derivative of that, we take the derivative of the whole function, which is d over dt. So we would have 2s ds over dt. Sorry, that should be a t. 2x dx over dt plus 2y dy over dt. And we can just cross out all of these t's here. So now this should look similar. We have s initial, we have x initial, and we have the y initial value. We also have the rate of x, which is this, and we have the rate of y, which is that. And all we need to do is just divide both equation by s initial, and we would have ds over dt is equal to x initial dx over dt plus y initial dy over dt, all of it divided by s initial. Now let's plug in the value for ds over dt. We have 225 miles times 450 miles per hour plus 300 miles times 600 miles per hour. All of that divided by S initial, which is 375 miles. So you punch that in the calculator, you should be able to get the rate at which distance S is changing with respect to time is equal to 750 miles per hour. What this is saying is the two planes are closing in each other at the rate of 750 miles per hour. A bonus question is, how long does it take until the two planes collided? So in order to find that, we just take the initial position, which is S initial. You divide it by the rate at which that position is changing with respect to time. So we would have 375 miles divided by the rate, which is 750 miles per hour. And if we punch that in the calculator, we should get about 30 minutes or 1.5 hours. Thank you for watching. This is my first video, and hopefully I will be able to make more of this for you guys. Take care.